In this video, we will be taking a look at utility network management for ArcGIS, focusing on network rules and topology. We'll be talking through the different rules and show how they work together to maintain data integrity during the editing process. This video is part of Eagle Technology's Utility Network video series. My name is Megan Cheong, and I am part of the GIS Technical Solutions team based in Wellington. Let's start by talking about network rules and what they are. Network rules are rules. They govern which features can connect or associate to other features at the asset type and asset group level. They play an important role in enhancing data integrity because they prevent data entry errors during editing, and they help validate existing data. The important thing to note is, if there is no rule in place, then features cannot connect. For instance, if there is no edge-to-junction rule for a particular pair of features, then you won't be able to snap these features together. There are various types of network rules, and you'll see examples in some of the demo up ahead. Firstly, we have edge-to-junction rules, which control the types of line features that can be connected to point features, and they're based on geometric coincidence. For instance, a high-voltage line connecting to a fuse. Then we have junction-to-junction connectivity rules, which allow two point features that are not geometrically coincident to be connected, using what we call connectivity associations. So point features that in real life may not be physically connected, like a transformer and a breaker, can still have that implicit connectivity be modeled. Edge-to-junction to edge rules constrain what type of line features can connect on either side of a point feature. In the water network, an example would be a main pipe connecting to a service pipe by a particular fitting type. Next, we have containment associations, and these allow us to model assemblies and complex devices like transformer banks or pump stations. They promote better representation of your assets and reduce map clutter. Finally, we can also model structural attachments. In the electric network, transformer banks are often attached to poles. Structural attachments allow us to model relationships between features in the structure network and domain network. In addition to network rules, every utility network has a topology. The topology is what manages feature information and maintains the connectivity between features. Extremely important, as this information is used for tracing and diagramming operations. Connectivity can be divided into network rules as well as feature restrictions. An example of this is line features cannot connect with polygon features. The topology is either enabled or disabled depending on your workflow needs. When editing, we want the topology to be enabled so that any edits made will be validated against the network rules and checked for errors. When it's disabled, we can perform administrative tasks such as bulk data loads or adding rules. Dirty areas indicate parts of your network where the topology has not been validated yet. They will appear after an edit is made in the form of a purple polygon. During validation, the network topology engine will evaluate whether or not the edits comply with network rules and feature restrictions. If they don't comply, we will see error features generated, which are represented as red points or lines depending on the error type. Errors are stored as a sublayer under the utility network layer and can be easily accessed, as I'll show you later. So what do these concepts actually mean when we are working with the utility network? Let's take a look at some editing workflows to see the network rules and topology working in action. I have some electric network data opened up in ArcGIS Pro. This is a subset of data from the electric distributor Network Waitaki, based in North Otago in the South Island of New Zealand. Firstly, let's access the network rules. Since they are stored in the utility network layer, we can right-click on it in the Contents pane and go to Properties. Under Network Properties, you'll see the rules. They're divided into the different types. And expanding the table, we can see that the asset group and asset type needs to be specified. This allows you a great deal of control to modify the rules to fit your business needs. Now I'm going to go in and add a new residential service point. I'll perform a simple service drop from this low voltage line to this house. I'll find the overhead residential service drop feature template, which will add a connection point, low voltage residential conductor, and residential service point for me. And as I hover my mouse over the low voltage conductor line, you can see that a snapping tip appears. And this indicates that there is an edge-to-junction network rule in place, allowing me to snap this connection point to this low voltage conductor. Once I confirm the edit, dirty areas will appear to let me know they haven't yet been validated. I'll click Validate, and since no rules were broken, no errors will appear, and now the edits are incorporated into the topology and can participate in traces. However, if I were to try to place an underground residential service drop, you'll see the snapping tip doesn't appear, because there's no rule in place allowing me to connect an underground conductor to an overhead line. So this prevents me from making editing mistakes. Let's take a look at some associations now. Remember, connectivity associations are implicit connections between 2 point features. Here I have an overhead transformer located between some low voltage and high voltage lines. To model the relationship between the connection points at the end of the lines to the transformer bank, we can use connectivity associations. To view them, I can go to the Utility Network Data tab, and in the Associations group, click View Associations. These dashed lines show up, indicating this implicit connection. These associations establish a connection through which the commodity can flow through, without all these points needing to be coincident. So how do we create and manage these associations? I can open up the Modify Associations tool. Clicking on the transformer bank, we can see the list of features it is associated with. I'd also like to mention that the utility network can also model terminal connectivity. This is especially useful for devices where there may be two drastically different entry points, like this transformer, which has a high and low side. Now let's add an association between the transformer bank and the riser at the bottom here. I can click on the riser to make it the active junction, and then click on the transformer to create the association. I will validate it, and because there is existing junction-to-junction connectivity rule, it will clear the dirty area, and if I refresh View Associations, we can see the newly created one. The Modify Associations pane can also be used to manage structural attachments, which are used to maintain a connection between a structural feature, such as this pole here, and the features that would be attached to it. So similarly, I can switch to the Attachments pane. I can select the pole, and one by one add the connection points, riser, fuse, and transformer bank as a structural attachment. As there are existing structural attachment rules to allow this pole to create attachments with these specific features, I can validate it, and now we can see the structural attachments as green dashed lines. What's advantageous about structures is that if you need to move the structure, you can do so, and at the same time move all of its attachments as well, making it simpler and easier to make changes to your network. And as usual, after making an edit to my network, I'll validate the edit. And once that's done, you can see that both the associations and structural attachment lines have moved as well. Let's take a look now at an example of a containment association. Here's the distribution substation of the network. Zooming in, we can see there's a switch, a circuit breaker, and some bus bar lines. But with the idea of containment, we can go inside this substation to view other features within, like a couple more switches and some line ends. These are features that might not necessarily be the most relevant when you're just panning around the network. You can also toggle the visibility of individual features contained, so that some can be visible even when you're out of containment mode. So containment associations give you the option to model denser features in a way that is represented by just one container feature, and it improves visibility on a map during editing. Plus, it's a more accurate representation of your network. Now that we've covered the main types of network rules, let's see what happens when an edit violates a rule. I'll return back to the residential service drop from earlier on. We already know that the network rules prevent users from snapping invalid features together. However, once the service drop has been added, someone could come in and attempt to change the low voltage service point into a different feature, such as a ground feature. After validation, we will see error features, because there is currently no rule in the topology allowing that. To obtain more details, we can actually access the attribute table of the errors from the utility network sublayer. In the attribute table, we can see exactly where errors are generated, as well as the global ID of the features causing the error. In addition, we can see the error text telling us which type of rule has been violated. This is the network topology in action, indicating to us the details of the invalid connectivity, which is helpful when we want to know how to fix it, which in this case would be changing the ground back to a low voltage service connection. So that was an overview of the utility network's network rules, the different types of rules, and how they help enhance data integrity while editing. That concludes this session. There's a lot more information that could be covered, but we hope this gives you a good overview of the key concepts regarding network rules and topology. For any more information or questions about the content covered in this presentation, please contact us here at Eagle at the email address on screen, utilities@eagle.co.nz. Also, please stay tuned for upcoming videos on other aspects of utility network management for ArcGIS. Thank you for watching and have a great day.